Hi, I'm Ken Boss, Vice President of Sales and Marketing with J&N White, and today I want to talk to you about a case study we recently published, specifically related to backlighting of a graphic overlay. Before I get into the actual product we manufactured, I want to talk a little bit about backlighting. Uh, Backlighting with fiber optics has been a common way to do membrane switches and graphic overlays for many, many years. And it's really something just like this, where you have a fiber optic cable, multiple strands of that fiber optic cable here backed with some form of backer, and then in this case, a single source LED. The cool thing about backlighting with fiber optics with LEDs is that you can have a very, very low power source to drive the LEDs, so you don't have to worry about alternating current or high voltages or anything like that. While fiber optics is a long-standing way to do this and a pretty cool way to do it because of the light it sheds, it's very difficult to incorporate these into an assembly because of this right here. A very thick strands, multiple strands of fibers coming together. So you need to accommodate for this thickness somehow in your overall mechanical stack up of the product. And in an era where everybody wants to get thinner, lower profile, it's really difficult to use this technology anymore. So the latest and greatest is still fiber optics, and this really begins the case study for this particular customer where they wanted to backlight this graphic overlay for one of their high-end products, is weaving fiber optics into a pad. They call it clad flat fiber. And if you look at the back of this assembly, you'll see this, we call it the t-shirt shape. That t-shirt happens to be the fiber optic pad. So with fiber optics, light comes in one end and comes out the other. It's a pretty straightforward way to transmit light. But what this clad flat fiber can do is that we've learned that if you flatten the top of the fiber, light will come out specifically where you flatten the top of the fiber, and that's actually done with an etching process. I'm going to show you a little bit how that works here. Plug this in, and when I plug this in, you're going to see, go ahead and flip the lights partway off, that with this particular product there's 3 LEDs. So again, very, very low power consumption, and you can see if you look closely, the areas through the back here that were actually flattened or etched on top to let the light out. And what that ultimately yields is a very, very unique low power consumption way to backlight a graphic overlay or a membrane switch panel. And the only issue with clad flat fiber optics is that it can be really expensive. So this particular customer ultimately got to a point where they designed a new product to replace this one, and they needed to get some cost out of this particular backlit graphic overlay as it was going end of life. So the other way to backlight products in a very similar fashion is with light guide layers, and that's what you're actually seeing here. So 3M and other manufacturing companies come up with materials that will carry light, diffuse light, very similar to the products that are used to diffuse light in the dashboard of your automobile, from single light sources to lighting up whole areas of product. What's different about this is that when you light it, you'll see that light emits in the entire piece, right? So what you have to do here to get this to work, where you are etching the clad flat fiber to allow light to come out in very specific areas, what you do here is you actually block light with screen printed layers of black ink, and that's what you see. The shadowing internal to the layers are actually some screen printed black halftones and gradients to get the light to come out exactly where we want it. You'll also see here that on the back of this, we now had 5 LEDs, whereas in the flat clad fiber we were able to get away with 3. So a little more expensive in terms of components, but in the end, using a light guide layer is extremely more economical than using the clad flat fiber when volumes start to decrease as a project like this goes end of life. So I just have a final example of this. now we have the same exact graphic overlay, but within that graphic overlay we have the light guide layer. And we really do get, again, 5 LEDs instead of 3, you can see here, but we really do get a very similar backlight pattern, even though we've switched from clad flat fiber or fiber optics to light guide layer. So that gives you a little background of fiber optics used in our industry for backlighting. The old strand method, the newer and much more effective clad flat fiber woven method, but then there's always the option to go to a more cost alternative light guide layer to achieve similar results. Not identical, but similar results.